Hello, grade 7. So this week we are starting with a new chapter, chapter 8, the electrical current. These are the objectives that we're going to cover during this week's lecture, so you guys will be able to identify the direction of an electrical current. You'll be able to measure the intensity of an electrical current by using an ammeter, and you'll be able to identify the ampere as the SI unit of an electrical current. Alright, so let's go back to this experiment that we did from before. So we have the electrical motor connected to a battery, and once we connect the electrical motor to a battery, then the motor will start to rotate in one direction. You can see it is rotating this way. Alright, what happens when we reverse the connections? Okay, so when we reverse the connections, the motor will rotate in the other direction. So the direction of rotation will change. All right, so this means that the current, the electrical current flowing in this electrical circuit, it has a direction, because once we reverse the connections, the direction of the rotation of the motor changed. All right, so in order for us to know how the electrical current flows in the circuit and in which direction, let's click on this simulation and move to the next slide. Okay, so I built up this circuit that consists of a battery, a lamp, a switch, and connecting wires. You guys can see that the switch is open, which means that the circuit is open. And when the circuit is open, it means that there is no electrical current flowing in the circuit. You can see that the lamp is not glowing, which means there is no electrical current flowing through it. Okay? All right, and we know from before that the lamp is the source of electricity. It gives out this electrical current, and when this electrical current flows through the lamp, then the lamp will glow. Now let's see what happens when I close the switch. You can see that the lamp is glowing, which means that there is an electrical current flowing through the circuit. Now, of course, we can't see the current with our naked eye. All right, so to be able to see it here in the simulation, you can click on this show current, okay, and click on conventional. And you guys can see this is the electrical current that is flowing through the circuit. All right, and you can see its direction. It has a unique direction. It goes from the positive pole of the battery, okay, and it enters through the negative pole of the battery. And when the switch is open, you can see that there is no electrical current flowing anymore, okay? When it's closed, I have electrical current flowing through the circuit, flowing through the lamp, and this is why it glows. All right, so we said that the electrical current flows in a specific direction. Okay, so it goes in one direction, in a very specific direction. And what is this direction? You guys can see that outside the generator, the current flows from the positive pole. You can see that it is flowing from the positive pole into the negative pole, just like that. Positive to negative. And this is called the conventional direction of the current. Okay, so this is its name. This is the conventional direction of the current. It goes from the positive pole into the negative pole. All right, so now we're going to talk about the intensity of this electrical current, like how strong it is. Like all electrical currents are the same? No, they are not. So take a look at this circuit. Okay, it consists of a battery, a lamp, a switch which is closed, and connecting wires. And if you want to show the current, the direction of the current, the conventional direction of the current, you can see it goes from the positive to the negative, and it's rather slow. Okay, so it's moving slowly. Now, I will be breaking the circuit, okay, and introducing another lamp similar to this one, okay, into the circuit just like that. So I have two lamps now. You can see that the lamp is glowing more, okay, because I added more, voltage. I increased the voltage of the battery because now I have two batteries. Then the lamp is glowing more. And if you can see, the current is a bit faster from before, okay, so it's flowing more. And if I break the circuit again and I introduce the third battery, so you guys will see now the lamp is really glowing, okay, so yeah, and the current flowing is much faster. What does this mean? This basically means that the electrical current has a certain intensity. It has a certain value. I can increase it, I can decrease it, and you guys saw how that happens. So, an electrical current is characterized by its intensity. It must have a certain value, okay, to characterize this electrical current. And we symbolize it by I. So, the electrical current is I. All right, and the lamp glows brighter when the intensity of the electrical current is greater. So as I increase the electrical current in a circuit, the lamp will start glowing brighter. Let's see. So at the beginning, when I had only one battery, which means you guys remember the battery, it has a voltage, and the voltage means that it is the force or the pressure that is pushing this electrical current in the circuit. So it's trying to push the current throughout the circuit. Yeah, so I have only one battery, which is, maybe of low voltage. So there is not much electrical current flowing through the circuit. Okay, this is why the lamp is glowing, just faintly. And it means that the intensity of the electrical current is not that much high. But when I put two batteries in series like this, then I will have more current flowing through the circuit, which means the intensity is higher, and this is why the lamp is glowing more. And in the third experiment, where I had three lamps connected right next to each other, I have a higher intensity of the electrical current here because there is more electrical current flowing through this lamp. This is why it's glowing more. All right, guys, so when the lamp glows brighter, it means that the intensity of the electrical current is greater. All right, so we're speaking of intensity of electrical current. Okay, so it must have a certain value. Like maybe when I had only one battery, it was, let's say, 2, and then when I had two batteries, it was 4, and then it was 6 at 3 batteries. So it must have a certain unit to it. Okay, so I can't have a physics in number without a unit. So it must have a certain unit. So let's get to know the units of this electrical current or electrical current intensity. Okay, so we're gonna get to know three units: the kilo ampere, the ampere, and the milliampere, where the ampere is the SI unit. Okay, guys, so we have three units: kiloampere, ampere, and milliampere. Now, going from kiloampere to ampere, we multiply by 1,000, to ampere to milliampere times 1,000. The other way, we divide by 1,000. And as I said, the SI unit is the ampere. Now we just said that the intensity of an electrical current, it has a certain value and a certain unit, but how can I measure it? I know that it is different for different circuits, but there must be a way for us to be able to measure it. Yes, there is, using this little device called an ammeter. So this device called an ammeter is used to measure the electrical current. Okay, and yeah, it simply gives me the value on the screen right here. Now the thing is with the ammeter, let's get to know the ammeter. This device actually called a multimeter, which can work as an ammeter. Okay, a multimeter is a device that's used to measure the voltage, which will be our next chapter, which is used to measure the resistance, which a chapter we're not going to take this year, and it also measures the current. Okay, so it has multiple functions, and the first function that we're getting to know in a multimeter is that it can be used as an ammeter. Ammeter is a device that measures the current I, so it gives me the value of the current. Okay, now how can I connect this in a circuit? Let's get to know that. First of all, an ammeter, it has two terminals. It has the A terminal, which is the positive terminal, and the COM terminal, which is the negative terminal. COM is short for common. Okay, so the A terminal and the COM terminal. A is positive, COM is negative. Let's see the two terminals. All right, so this is the COM terminal. You guys can see right here, this is the COM. Okay, so you simply connect this using connecting wire. And then you have the A terminal. You have two A terminals. Okay, one is in milliamperes and the other one is amperes, and it depends on the intensity of the current that you're trying to measure. So if the intensity is small, okay, if the intensity is less than 200 milliamperes, so you use this slot. And if the intensity is, greater than 200 milliamperes, then you use this slot. All right, so, but how can I connect it in a circuit? We're gonna get to know that. But before we do, let's get to know the symbol for this ammeter. So it looks like that, a circle with an A inside of it. So this is an ammeter, this is its symbol. And it has two terminals. Of course, this is the first one, this is the second terminal. One of the terminals is A. You can call it A or you can call it plus, positive. And the other one is COM or negative. So it's up to you to call it, to symbolize it as COM or negative. Now, to be able to measure this value of the electrical current, to be able to measure the intensity of the electrical current, we said we can use an ammeter. But how can I connect this ammeter in a circuit? I know that there is an electrical current flowing in the circuit, and I have this device called an ammeter that measures the electrical current, but how can I connect it in the circuit to be able to measure its actual value? This ammeter is connected in series in the electrical circuit. What do you mean by in series? Basically, you have this electrical circuit that consists of a battery, a lamp, and a switch and connecting wires. The first step that you need to do is to open the switch and break the circuit. Open the switch and break the circuit. Just remove a connecting wire, or just open up the circuit. Okay, just like that. Now you bring this ammeter that you have. This is the ammeter that has two terminals, right? And you connect it just like that. This means that the ammeter is connected in series in this circuit. All right, but the ammeter, it has two terminals, the positive and the negative, the A terminal and the COM terminal, which is connected to which? Great. So the negative terminal of the ammeter must be connected to the negative pole of the battery, and the positive terminal of the ammeter must be connected. If you follow the line, you would see it is on the same side as the positive pole of the battery. Okay, so this is the COM and this is the A terminal. This is how an ammeter is connected. After doing that, okay, you guys have to choose the correct scale on this ammeter. I'll be talking about this more in the upcoming slides. And then you can close the switch, okay, because otherwise the ammeter can get damaged. So these are the three steps that you need to take to be able to read the value of the electrical current. All right, So an ammeter is connected properly in a circuit if the current moves into the ammeter through the A terminal and leaves the ammeter through the COM terminal, enters the ammeter through the positive and leaves it through the negative. Of course, if we close the switch, then the current will start flowing in the circuit and the lamp will get lit. And of course, the current will be entering or moving through the ammeter through its positive terminal and then leaving its negative terminal, just like that. Okay? All right, so how can I choose the correct scale or the correct caliber? As I said before, this is a multimeter that can function as an ammeter, and later on in the next chapter you guys will see that it functions as a voltmeter, which measures the voltage. So it has different functions. To be able to use it as an ammeter, we have to take this and move it to the A side, to this side right here, and not any A side actually, to the A side that has a line right next to it and not, you know, a little curve. Okay, so this one right here. So we have to move this into, you know, any number that is written here. Now, if you guys look at these values that you have right here, we have 10 amperes, 200 milliamperes, 20 milliamperes, so the numbers are getting smaller, 2 milliamperes, and then you have 200 microamperes. Microamperes is smaller than milliamperes. So you can see these are called calibers. Okay, so calibers are basically, they represent the maximum value that this ammeter can read. So if you guys chose the 200 milliamperes, it means that you cannot measure, you know, a current that is greater than this value. So it represents the maximum value that this ammeter can read. And if the intensity is greater than the value chosen, okay, then the ammeter will get damaged. To prevent the ammeter from getting damaged and to get the most accurate measurement, we first have to choose the biggest scale possible, which is the 10 ampere in this case. By choosing the 10 ampere, this is the biggest scale possible, and then you start going down from there, okay, until you get the most accurate measurement, which is basically the caliber that is just above the current intensity being measured. Okay, this would be the best caliber. So you start from the biggest value and then you go to the smaller values until you get the most accurate measurement, which is basically, you know, the value that is closest to the intensity measured but of greater value. All right. Okay, so yeah, this is how we choose the, you know, the scale or the caliber of an ammeter. Okay, so I'm using the application, the phone application. And now you guys can see we have this circuit that consists of a battery, a lamp, and a closed switch. Okay, and yeah, we have connecting wires. It's a closed circuit, so the lamp is glowing. I will be opening the switch. Now to be able to connect the ammeter, you can see this is the ammeter. To be able to connect the ammeter and to be able to measure the value of the current, first we need to open the switch and then we need to break the circuit. Let's break the circuit. Okay, so this is, I removed the connecting wire and now I will be connecting the positive pole, just 1 second, the positive pole of the battery to the A terminal of the ammeter, or to the positive terminal of the ammeter, and the negative terminal to the negative pole. Okay, so if you follow the line, you would see that it is connected to the negative pole, just like that. Okay, before closing the switch, I'm going to choose, I already chose the 10 ampere caliber, okay, on the ammeter. So this is the 10 ampere caliber, and now I'm going to close the switch. This is the highest caliber to be used, okay, so this is the safest one. I'm going to close the switch. You guys can see that the ammeter is reading a value of 0.28 amperes. 0.28. Now, before moving to a smaller scale, think about 0.28. It is how many milliamperes? It is 280 milliamperes, which is greater than 200 milliamperes. So I cannot use a smaller scale. If I used a smaller scale, then this ammeter will get damaged. Okay, so yeah, this is how we read the intensity of an electrical current. All right, so what if I decided to reverse the connections of the ammeter? What will happen to the ammeter? We said if we chose a smaller caliber than the value of the intensity measured, then the ammeter will get damaged. Now let's see what happens if I reverse the connections of the ammeter. So I did open the switch, I did break the circuit, and now I'm going to connect the negative terminal or the negative port of the ammeter to the positive terminal of the battery, which is usually connected to the negative one, but now I'm connecting it to the positive, and the A terminal of the ammeter to the negative terminal of the battery. So if you follow the line, you would see that it is connected to the negative pole. Okay, now I chose the biggest scale. Okay, I'll be closing the switch and let's see what happens. Okay, so it gave me a negative value. So the ammeter is not damaged. It simply gave a negative value because I reversed the connections. Basically, it means that the current is flowing, it's going from the negative terminal to the positive terminal of the ammeter, and this is why it's giving a negative value. This is not the proper way to connect an ammeter, but it's not like the end of the world, because you can simply break the circuit again and reverse the connections. Okay, so when the ammeter gives a negative value, all you had to do is to reverse the connections, and that's it. All right, so the three cases that we just talked about. First case, when the ammeter, you can see that it is connected, in series in the circuit, but the switch is open, so there is no electrical current flowing through the circuit, and you guys can see the COM is connected to the negative pole and the A is connected to the positive pole, so this is the correct and the proper way to connect an ammeter. But the switch is open. You guys, you saw in the simulation when the switch was open, the ammeter read 0. Okay, so because there is no electrical current flowing through the circuit, and this is why the lamp will not glow. Now the case where we close the switch, the ammeter, when it is connected this way, you guys can see that the COM is connected to the negative pole and the A is connected to the positive pole. COM is like the negative, A is like the positive. So negative, to negative and positive to positive, which means that this is the proper way to connect an ammeter and it will give me a positive value. Now, if I switch the connections, you guys can see here, A is connected to the negative and COM is connected to the positive. What will happen to the ammeter? It simply gives a negative value. To correct this, connection, I simply reverse the terminals. Okay, so this becomes the COM and this becomes A, then it will give a positive value. And that's it. We're done with this chapter. It's a one lecture chapter. I hope you guys found it interesting, and I encourage you to use all the simulations and the applications to be able to understand this more. Yeah, so I will see you in the live session. Take care and bye bye.